We've all marveled at the majestic rings of Saturn, but what if our own planet had a similar halo? It sounds like science fiction, but could there be more to this idea than we initially think? The origins of ring systems have puzzled astronomers for decades, and yet we've only scratched the surface in understanding why some planets sport these celestial ornaments while others don't. Take Saturn, with its majestic rings stretching across hundreds of thousands of kilometers. It's a spectacle that never fails to leave me awestruck. But what if I told you that Earth itself was once thought to have had a ring system? The idea sounds absurd until you realize that our own moon is actually a remnant of a massive collision that could have triggered the formation of rings around our planet. That number, 10 times the mass of Mars' atmosphere, sounds like a wild guess, but it's a tantalizing prospect. What if Earth's ring system was simply too ephemeral to be detected? The fact that we can't pinpoint when or why these systems form raises more questions than answers, and I think that's what makes them so fascinating. Saturn's rings have always been an enigma. We've studied them extensively, but their composition and structure continue to defy our expectations. The sheer scale is mind-boggling, thousands of kilometers wide and stretching out into space like a cosmic halo. But what exactly are they made of? Contrary to the tidy picture we had of neatly arranged ice particles, it turns out that Saturn's rings are more akin to a cosmic mess of rock and dust. That number sounds absurd until you realize that this debris has been shepherded by tiny moonlets, creating the illusion of order amidst chaos. And yet, despite our best efforts, there's still much we don't know about these mysterious rings: their age, their formation, even how they manage to stay intact in the face of intense gravitational forces. The more we learn, the more we're forced to confront just how little we truly understand about this vast and complex system. For Earth's rings to form like Saturn's, it would take an enormous amount of debris orbiting our planet. That number sounds absurd until you realize that Saturn's rings are made up of tiny ice particles and rock fragments, not massive asteroids or comets. It's estimated that the rings of Saturn contain billions of objects, ranging from boulders to dust specks. The sheer scale is mind-boggling, but it raises a crucial question. What would be the source of this debris? Would it be leftover building blocks from our planet's formation? Or would it require some catastrophic event to strip away material from Earth itself? And even if we had enough material, could the gravitational forces holding Saturn's rings together be replicated around our own planet? Now, let's dive into how Earth's hypothetical rings would impact our moon's tidal forces. At first glance, it might seem like a non-issue. After all, our moon is already experiencing tidal forces due to the sun's gravitational pull. But here's the thing. If Earth had rings, the additional mass and gravity they'd introduce could have a profound effect on lunar tides. We're talking potentially catastrophic effects on coastal ecosystems, not to mention the altered rotation periods of our oceans. The numbers sound absurd until you realize that even a relatively thin ring system could amplify tidal forces by up to 10%, a small margin, perhaps, but one that could have significant consequences for marine life and human settlements alike. And yet, we still don't know exactly how this would play out in practice, or what long-term effects such a scenario would have on our planet's climate and geology. A ring system like Saturn's would undoubtedly have a profound impact on Earth's climate. The sheer scale and complexity of such a system would introduce new variables into atmospheric circulation patterns. Imagine, if you will, the delicate balance between incoming solar radiation and outgoing heat being disrupted by the presence of these massive, orbiting rings. That's not to say it wouldn't happen. After all, Saturn's own moon, Titan, has a significant effect on its atmosphere. But would it be enough to drastically alter our climate? The fact that we can't even simulate such a system with current models speaks volumes about the complexity of this hypothetical scenario. And yet, some researchers argue that a ring system could actually help regulate Earth's temperature by scattering incoming radiation. That number sounds absurd until you realize how much energy is involved. It's hard to imagine what kind of climatic consequences would follow from such an interaction. But one thing's certain: The effects on atmospheric circulation would be nothing short of fascinating, and a crucial area for further study if we ever were to stumble upon evidence of such a phenomenon. If Earth were surrounded by rings like Saturn's, our planet would be constantly bombarded with debris from those celestial structures. It's estimated that each ring particle carries an enormous amount of kinetic energy, capable of causing significant damage upon impact. That number sounds absurd until you realize that it's not just small rocks we're talking about. Some particles are hundreds of meters in diameter. The potential for destructive power is staggering, and yet it's often glossed over by those who propose Earth ring systems as a viable solution to our celestial woes. But what does this mean for our planet's habitability? If the rings were actively shedding debris, would we be facing an existential threat? Or would life find ways to adapt? One thing is certain, an Earth ring system would fundamentally alter our understanding of planetary stability and the risks associated with it. If Earth's rings were comparable in size and mass to Saturn's, it's estimated that they would require an enormous amount of energy to maintain their stability. I mean, think about it, the energy requirements would be staggering, on par with the energy output of a small star. That number sounds absurd until you realize that it's not just about generating the initial momentum, but also about continuously replenishing and dissipating the kinetic energy over billions of years. The sheer scale of it is mind-boggling. But what if I told you that there are scenarios in which Earth's rings could have formed, not through some catastrophic event or asteroid impact, but through a gradual process that's still somewhat debated among scientists? Some theories suggest that Earth's early atmosphere was more hospitable to ring formation than we give it credit for. That raises an interesting question: what would be the implications of such a scenario on our understanding of planetary evolution? Could it challenge our current understanding of how planets form and change over time? The more we examine our solar system's ringed beauty, Saturn, the more questions arise about its uniqueness. Why don't more planets have similar systems? That number sounds absurd until you realize it's not just a matter of size or mass. In fact, several gas giants and other star systems have been observed with their own rings. However, these extraterrestrial ring systems are often vastly different from Saturn's, making us wonder what sets our solar system apart. The prevailing theory suggests that the key lies in Saturn's moon-driven dynamics, but it's hard to shake off the feeling that we're still missing a crucial piece of the puzzle. As we continue to explore and learn more about these celestial bodies, one thing becomes increasingly clear: there's still much we don't understand about the mysteries of our cosmos. And so, we're left with a nagging question: what other secrets lie hidden in plain sight? Rings in other contexts, that's where things get really interesting. The moon of Jupiter, Amalthea, has its own faint ring system. At first glance, it sounds absurd, a tiny rock with a handful of particles orbiting around it. But think about the implications. If we can find rings on a moon barely 200 kilometers in diameter, what does that say about the likelihood of Earth having them too? Perhaps our atmosphere is just a thicker version of Amalthea's ring system, condensed into a solid surface. And then there are asteroids. Some of these small bodies have their own fragile rings, formed from ejected material or even frozen gases. These analogs raise more questions than answers. What creates such delicate structures in the first place? Is it just a matter of size and scale? Or is there something fundamental about our solar system that we're still missing? Asteroid impacts and comets might seem like an afterthought in shaping a planet's ring system. But bear with me on this, their influence could be far more significant than we think. I mean, consider that Saturn's rings are thought to have originated from the remains of a moon that was torn apart by Jupiter's gravitational forces. Now, extrapolate that idea to our own solar system. If Earth had rings like Saturn, it's likely they would have been formed in a similar way, and that means asteroids and comets would have played a major role in their creation. But here's the thing. We don't have any direct evidence of this process happening on our own planet. It's all theoretical, based on observations of other systems. And yet the implications are fascinating. If Earth's ring system were indeed seeded by asteroids and comets, it would suggest that even the most seemingly stable planets can undergo radical transformations over time. If Earth had rings like Saturn's, our planet's core would likely be severely affected. The sheer mass and gravitational pull of these rings would start to tug on our coarse molten iron, potentially causing massive disruptions in Earth's magnetic field. That number sounds absurd until you realize that a slight weakening could have catastrophic consequences for life on Earth as we know it. Our magnetic field acts as a shield against the sun's radiation and charged particles, protecting us from harm. A diminished field would leave us vulnerable to increased cosmic radiation, which could disrupt the very fabric of our ecosystems. So, how would this hypothetical scenario actually play out? Does the core adapt by releasing more energy through geological activity, or does it succumb to the external forces? We still don't know. If Earth were to develop rings like Saturn's, we'd be witnessing a gravitational tug-of-war on an unprecedented scale. The sun's gravity would interact with the ring system in ways we're still trying to understand. That number sounds absurd until you realize it. The sun's mass is approximately 330,000 times that of our moon. Its gravitational influence on Earth is staggering. But what if we added a vast, diffuse structure like Saturn's rings into the mix? Would the sun's gravity be able to hold them in place, or would they destabilize and collide with our planet? One theory suggests the rings might actually help stabilize Earth's axis, but this raises more questions. How would they interact with the moon's orbit, and what would be the long-term effects on our climate? The more we consider these gravitational interactions, the more we realize just how much we've yet to grasp about the cosmos. Simulations and models have attempted to recreate a hypothetical Earth ring system, but it's essential to approach these findings with a critical eye. One study published in the Journal of Geophysical Research simulated a ring system around our planet using advanced computer algorithms. The results show that such a system would be incredibly unstable, with particles colliding at high speeds and causing massive destruction. That number sounds absurd until you realize it's not just the rings themselves that are the problem, it's the sheer amount of debris they create in Earth's orbit. It challenges our understanding of planetary formation and stability. For instance, how would a ring system affect Earth's rotation and axial tilt? We're talking about fundamental aspects of our planet's behavior here. Yet, some researchers argue that these simulations might be too simplistic, neglecting the complex interactions between rings and atmospheric conditions. The debate remains: can we truly replicate the intricacies of an Earth ring system, or are we merely exploring hypothetical what-ifs? The idea that our own planet could have rings like Saturn's may seem far-fetched, but let's consider what we can learn from other worlds. Jupiter, Uranus, and Neptune all boast their own ring systems, albeit quite different from Saturn's majesty. The sheer scale of these systems is staggering, hundreds to thousands of individual rings, stretching out into the vacuum of space. That number sounds absurd until you realize that each one represents a unique opportunity for scientists to study the complex interactions between celestial bodies and the effects of gravity on their orbits. And yet, despite this wealth of data, we still don't fully understand how these systems formed in the first place, or even what exactly constitutes a ring system in the grand scheme of our solar system. As we've explored the possibility of Earth having rings like Saturn's, it's clear that the likelihood is extremely low. But let's not dismiss the idea entirely just yet. The presence of rings around a planet can be a sign of a catastrophic event in its past, perhaps a massive collision or gravitational disruption. That number sounds absurd until you realize that our own solar system has been shaped by countless encounters with comets and asteroids. If Earth had experienced a similar fate, it's possible that we might have inherited some kind of ring system as a result. The problem is, the laws of physics as we understand them suggest that such an event would have left behind clear evidence, but we don't see any signs of extensive debris or gravitational disturbances in our planet's vicinity. It's a paradox. On one hand, the possibility of Earth having rings adds a fascinating layer of complexity to our understanding of planetary formation. On the other hand, it challenges our current grasp of the fundamental laws that govern our universe. Join me in exploring this fascinating thought experiment as we delve into the what-ifs of an Earth with rings like Saturn's. Together, let's unravel the complexities and implications of such a scenario.